Hi, everybody. This is Mr. Folly, and welcome. Whoa, and it's too good to be true. Whoop, my goodness gracious. This is Mr. Folly, and welcome to 10.3 equilibrium calculations. Okay, so determine K given initial and final concentrations. So this is how you've got to do it. I want to determine K. So K, remember, is the ratio of products over reactants. So we're going to make an ice diagram. An ice diagram is going to be the initial amount, the change, and the equilibrium amount. You'll see this in a minute. Using coefficients for your change line. You're going to write the K expression, substitute the bottom line of ice, which is the equilibrium line, into your KEQ equilibrium expression. So let's do an example. Find the equilibrium constant KQ for the following equilibrium. The initial concentrations of AB and C2D are 0.6 molar. So I'm just making a note, AB and CD are 0.6 molar before they are mixed. And when equilibrium is reached, the equilibrium concentration of AD2 is 0.2 molar. Okay, so I got something a little different here. AD2 is 0.2 molar. Use an ice table for your calculations. Okay, so let's take a look. So I stands for initial. Initial means the first thing you start with. So initially, in AB, I have 0.6. Initially, in the beginning, for CD, I have 0.6. Now, it doesn't tell me how much I have for the other stuff, so I got nothing, and I got nothing. Okay? My change line. Okay? So the change is going to be based on the coefficients. So this has a coefficient of 2. So this is going to, because it's a reactant, it's going to go down. It's going to lose 2x. This is a reactant. Uh-oh, it's a solid. I'm going to ignore my solids. Okay? This is a product. It has a coefficient of 1. It's going to go up 1. This is a solid. I'm going to ignore my solids. Now, if you notice, it says when equilibrium is reached, the equilibrium concentration is 0.2. So now I need, so 0.6 minus 2x is going to be 0.6. This is going to seem kind of silly, minus 2x. Can you tell pretty easily that x equals 0.2, right? So x equals 0.2. So down here in this spot right here, I have 0.6 minus 2 times 0.2, right? 2 times 0.2 is 0.4. 0.6 minus 0.4 equals 0.2. So underneath this, I'm going to put another one. I'm going to put 0.2 here again. So do you see now in the end, oops, zoom medium, I thought I could change my color here. I guess I can't. I'll go purple. Do you see how my equilibrium lines are those? Okay. So I'm looking for the KEQ. Now notice, solids not involved, solids not involved. I'm going to write my K expression. K equals products A to D. I put B as in boy instead of D as in dog. A to D over reactants AB raised their coefficients. I'm going to get rid of this part right here. Raise their coefficients 1 and raise their coefficients 2. Okay. So now what I'm going to do is I'm now going to substitute. A2D is 0.2 over AB is 0.2 squared. Okay. And that's going to be 1 over 0.2. Let me get out my calculator to confirm. So 0.2 divided by 0.2 squared is 5. Okay. So let's take a look at this again. We have our steps on how to do it. Make an ice diagram. Okay. Here's my ice diagram. Right. Write the K expression. Here's my K expression. Substitute the bottom line into the expression. Calculators assemble. Okay. Don't worry, we'll do a bunch of these. Determine final molarities when given K and a starting concentration. So now instead I'm going to find these guys right here, and I'm going to be given all of the top, and I'm going to be given K. Write an ice diagram using coefficients for change and X for the relative change. Write the K expression, substitute the E line into K expression, make sure you answer which molarity you need. So here we go. Now we get a real chemistry one. All right. So let me just do this and bail this. Get him out of the way. Get all the way out of here. Come on, my friend. Okay, so 0.50 moles of NO2 is placed in a 2-liter flask. Notice these dirty dogs, remember this has to be in molarity. Remember how it's in brackets, it's in molarity. So right away, I'm going to change that to molarity. So moles equals MV, 0.5 equals molarity times 2. Molarity equals 0.25. Okay, so 0.25 molar of NO2 is placed in a 2-liter flask to create NO and O2. Calculate the equilibrium concentrations if KQ equals that. So I'm going to start with 0.25. Again, so initially I have 0.25, and it didn't mention these, so I don't have any. The change is based on your coefficients. Uh-oh, I don't see any coefficients. It's probably not balanced. 1 nitrogen, 1 nitrogen. 2 oxygens, shoot, 3 oxygens. Okay, so let's try this. I'll put a 2 here to start. 2 nitrogens, 2 nitrogens. 4 oxygens, 2 oxygens, 4. Oh, okay, there we go. So now I'm balanced. Yay, I'm balanced. Okay. The change here, remember it's going to be based on x's, minus 2x. Over here, based on coefficients, plus 2x. Got a coefficient of 1 plus x. At equilibrium, I have the very strange 0.25 minus 2x, seems not helpful, 2x and x. Write the ice diagram, right? And use x for your relative change. Now we're going to write the K expression. K equals products, NO squared, O2, over NO2 squared. Yikes. Okay, now I'm going to put these numbers in. KEQ is right here. 1.2 E negative 5 equals NO, 2x, 2x quantity squared, O2, x, all over 0.25 minus 2x quantity squared. This is a monstrosity that you wouldn't believe. Okay, so when I look at this, you should be excited. It's like, oh yeah, look, I can factor this out. I can collect my terms. I can get this into an ax squared plus bx plus c, and I can use the quadratic formula. To that I say, no. We are going to learn how to use the solver. Get out your calculators. I said, get out your calculators. Get out your calculators. I said, get out your calculators. You're going to hit the button that says math. You're going to hit up. And you're going to hit enter, where it will say numeric solver. Okay, first I'm going to do the TI 84 plus CE version. Okay, when I hit enter, it will have 2 boxes. It's going to say equation 1 and equation 2. Equation 1 is the left-hand side. All right, so I got this box. That's going to be the left-hand side. 1.2 E negative 5. And I have this other box, and it's going to be the right-hand side. Two x quantity squared times x divided by quantity, 0.25 minus 2x quantity squared. Okay? So I'm going to type that in. So I'm clearing mine. 1.2 E negative 5, down arrow, quantity 2x quantity squared times x, quantity x quantity, oops, I put squared. I mistyped it, so I got to start all over again. 2x quantity squared times quantity, x quantity, divided by quantity, 0.25 minus 2x quantity squared. Okay? And then I have to put it, it says x equals. And my x equals will always be, when this is small, 0.0001. So this is a guess to say, what do we want to be close to? I'm going to hit alpha enter, and it changes my answer to x equals 0.00555 molar. That's x. Okay? So what that means is, that is what oxygen is. 2x is what NO is. So second quit. So then I do 2 times X, and I get 0.0111 molar. And then the first one was NO2. NO2 equals 0.25 minus 2X. Remember how that's my equilibrium line? Not squared, just 0.25 minus 2X. So I do 0.25 minus 2X, enter, and I get 0.23 molar. And there's my answer. Okay, how to do it in a TI-84 not plus. If you got a brown one, it's just a little bit harder, okay? A little bit harder. So what you do, you still do math up, and you get the solver, okay? And it's going to see EQN 0, right? And what you have to do is you have to zero this out. So you're going to have to take this to the other side. So I'm going to parentheses my left-hand side. So I'm going to parentheses this dog right here. Parentheses 2x squared times x divided by parentheses 0.25 minus 2x parentheses squared. Close my parentheses, and then notice I have to subtract this. Minus 1.2 e negative 5. And then it's going to say x equals, and you're going to put in again 0.0001. And then you're going to hit alpha. That's how I got it again. Enter. I don't think I said that very well on this one. Alpha, enter. And what that is that's really the solve button. And you get the same answer for x. And the same thing we did here. That's it. Toodles.